So the trig functions are the most important part about this whole notes page. If you look at the picture there on the left, the R makes a right triangle with that dashed line straight down, and the X. So the Y is the vertical distance, the X is the horizontal distance, and then R is the hypotenuse, right? So if we read this over here, it says let theta, that's the angle. So there's the Greek letter theta again. So let theta be an angle in standard form, and P is xy, be a point on the terminal side of theta. The distance from P to the origin, R, can be found using the formula. And this is just the Pythagorean theorem. So if we take the x squared plus the y squared equals the r squared, and if you go look back at that triangle, right, here's a leg, and there's a leg. X is a leg, y is a leg, r is the hypotenuse. So you got a squared plus b squared equals c squared. So that's nothing but the Pythagorean theorem. So again, looking at that triangle, let's think about what is the sine of the angle theta. So angle theta is going to be this angle here, but to find the sine, you just want to do the opposite over the hypotenuse, right? The opposite of the reference angle. Okay, so this is the angle that we're actually looking at. I'm just going to call it capital A. So the reference angle is the angle that you think about when you're doing sine, cosine, and tangent for these. So y is the opposite, sine's opposite, let me write that down, opposite over hypotenuse. And what is the opposite? That's the y. And what's the hypotenuse is the r. So y over the hypotenuse r. And then the cosine is the adjacent over hypotenuse. Right, this is from SOHCAHTOA. And the adjacent, go look at your triangle over there again. The adjacent is the x value. So we're going to have x over the r. X over r. And then tangent, looking at that triangle, tangent's opposite over adjacent. Let me write that first. Opposite over adjacent. So what's the opposite value? The opposite is the y, and the adjacent is the x. So this is going to be y over x. The opposite over the adjacent. Don't worry about the cotangent, the secant, or the cosecant. We'll skip those for now. Okay, these last ones are good questions. It says if P is 5, negative 2, it's a point on the terminal side of the angle theta in standard form. Find the exact values of the trigonometric functions of theta. So let's use our xy over here, or make your own there. So 5, negative 2, you're going to go to the right 5 and down 2. So that's going to be a point on the terminal side of the angle. So there's the terminal side of the angle. You really only need to worry about the reference angle. So the reference angle is the distance between that terminal side and the x-axis. So then let's think about this as being, change colors here, a right triangle. Right there. So then what would the x distance be? Well, we went to the right 5, right? So that x distance would be 5, and the y distance we went down 2, so that's going to be negative 2 for the y. We don't know what the r is, but that's the hypotenuse. Okay, so the sine of theta would be the opposite over the r value. Well, we don't have the r value, but we can find it, right? Pythagorean theorem, a squared plus b squared equals c squared, or I wrote it up there as x squared plus y squared equals r squared. Okay, so you can think about it the same way. X squared plus y squared equals r squared. It's the same thing. So the x is 5, and y is negative 2, and equals r squared. So 5 squared is 25. Negative 2 squared, negative 2 times negative 2 is going to be a positive 4, equals r squared. So you add 25 plus 20 plus 4 and get 29. So r squared is 29. And then we have to square root that to get the r. So r is equal to the square root of 29. Now you could change that to a decimal. I'm just going to leave it that because it's asking for the exact values. Okay, so we want the exact value, so we're going to use this square root of 29 for the r value. And we can label that on our triangle over there to the left. So the sine is the opposite over the hypotenuse. Right, so that's going to be negative 2 over the square root of 29. Okay, now that would be perfect, except we can't leave a radical in the denominator, if you remember that from the special right triangles. So you have to multiply both sides, both the top and the bottom, by radical 29. And so on top you're going to have negative 2 radical 29. On the bottom, radical 29 times radical 29 is just going to be regular 29. So right there would be the exact value of the sine of theta. Okay, it's not a terribly pretty answer, but it's the exact value. All right, moving on to the cosine. The cosine was, if we go back up here, cosine is x over r, or look at your triangle. And that'd be the x was 5, the r is radical 29. So the cosine is going to be 5 over radical 29. Again, just like with sine, you can't leave the radical in the bottom, so you multiply both the top and the bottom by radical 29 to cancel it from the bottom. Top, you're left with 5 radical 29. On the bottom, you're left with just regular 29. So you can't reduce 5 over 29, so there you go. You're done. Okay, and then if you go to the tangent is the y over the x. And if you look at the triangle, you can see that again is the opposite over the hypotenuse. Right? So simply the x. Oh, I had it right the first time. It's the y over the x. Right? So the y was the negative 2, and the x was 5. Okay, and that one you don't have to simplify anything. There's no radical to worry about. So that one's pretty easy. You're done there. Don't worry about the cotangent, secant, and cosecant again. Okay, so finish those up. Think about those and take notes on those because we're going to be using them in the future.